Welcome to part 4 of Modeling with CNOSSOS EU. I'm Erwin Hartog van Banda and I will be your presenter for this fourth session. This fourth webinar is the final webinar which started, the first part started the start of this month, was on the introduction of the CNOSSOS method. Then I went into part 2 for the import section. Then part 3 last week for the tiling and calculation, and now today on the EU population exposure. And after today, the videos will be available on the website, and I think that will be start of next week that all recorded sessions will be available on our CNOSSOS website. I also will send my presentation to all people who registered for the 4 sessions. So it was all to do with this project flow, and I explained how to import GIS data, how to create the receivers at facades, how to tile the main model, how to calculate the models, how to import the tiles in the main model, and now we are on point 6, EU population exposure. Before I explain more about the system, I want to show you in Predictor how you can calculate the EU population exposure. This is the model that was calculated in the session last week. If you go to the table of results, you will see that all the receivers at facades now have a day, evening, night, and LDEN value. So all receivers are calculated. Then, in order to calculate the number of exposed people, I will zoom in a little bit to explain a little bit more. Here you see and I will make the receivers with the default coloring. Then you will see them better. So you see all the receivers around facades, and these are all the building blocks. And within the building block, there are address points. So these are the address points, and on an address point, information is provided on the number of people and the number of dwelling belonging to that building block. And if there are multiple address points, in this case 4 address points in one block, then they're accumulated. So the number of people and the number of dwellings are assigned to this, so the accumulated number of people and dwellings are assigned to this building block. If I open the building block itself, on the information, you see that this is a residential designated use building block, and the building type is apartments single facade. And you need that information in the EU population exposure option. I'll come back on that later. But first, let me show you how it looks when you start the EU population exposure option. So you go to the result menu and you click on EU population exposure. Then first you have to select those buildings that have a residential building use. Well, in this case it's easy. You see all the types created in your model. So there are also commercial buildings, there are non-residential buildings. But in this case, we select the residential building, the designated use, residential designated use. Then you have to select which building type, because that was the second important property of a building, belongs to method 1, what type belongs to method 2, and what type belongs to method 3. And I will explain more about these methods in the coming, in this presentation, of course. But for instance, apartment single facade, they have to be calculated according to method 2. Apartments multi-facade have to calculate it according to method 3. So you see with these arrows up and down, you can move a certain building type to a certain method. Now you're almost done to calculate the EU population exposure. There's one option you can set. You can select a group. In this case, I will select the main group, but you can also select the group industry, rail traffic, road traffic, in order to calculate the EU population per type of source. And you need to provide that information per type of source. So you need to use this option 3 times. one for industry, one for real traffic, and one for road traffic. But in this case, I'll just do the complete group, the main group, all sources. Then I click on Start, and now Predictor is checking all buildings in the model. He's checking if they are residential. Then he's checking how many address points are in that building. Then he's accumulating the number of dwellings and people in that building. Then he's checking what are the receivers around facades for that building. And then, depending on the building type, calculating either the most exposed facade or the length of represented facade or the medium value methods. Let's leave Predictor to it, and I'll just switch back to my presentation and I'll explain you more about those methods. So I go back to my presentation. So in Predictor, you have to select between method 1, 2, and 3, and they are based on the text, of course, in the CNOSSOS method. In this case, the CNOSSOS method does not provide you with nice pictures. No, you have to read the text. So in the chapter, in the CNOSSOS method, where it says assigning dwellings and people living in dwellings to receiver point, there it describes how it's done. So it says, where information on the location of dwellings within building footprints is available, that dwelling and the people living in that dwelling are assigned to receiver point at the most exposed facade of that dwelling. That's the first method. Those could be detached houses, semi-detached houses, terrace houses, or apartment buildings where the internal division of the building is known. Or for buildings with floor size that indicates a single dwelling per floor level. So basically, method 1, the maximum the most exposed facade, method 1 is used for either single dwellings, where only one family lives, or, for instance, an apartment block where one dwelling per floor exists. Those type of buildings belong to method 1. Where no information on the location of dwellings within footprints as explained above is available, one of the two following methods shall be used, and those we call method 2 and 3 in Predictor. And I click to the next slide, method 2, and I repeat this text, where no information of location on the location of dwellings within the building footprint is available, then one of the two following methods shall be used. So method A, that is in Predictor, we call it method 2. Available information show that dwellings are arranged within the apartment building such they have a single facade exposed to noise. And in that case, so let's say you've got a building block over here, and there are apartments in this building block, but every apartment only have a single facade exposed to noise, then you have to use what we call the length of represented facade option. And I will explain that later in my presentation. So that's method 2. Personally, I think that it's very difficult to get this type of information. So I really doubt if we will be using method 2 in Europe, but maybe some countries have this type of information. Because I think that they will more use method 3. That's a new method, method 3, that's added to the CNOSSOS method at the end of last year. There was this amendment. Available information shows that dwellings are arranged within an apartment building such that they have more than one facade exposed to noise, or no information is available on how many facades of the dwellings are exposed to noise. And that's why I think that this method, method 3, will be used the most. Because in this case, for each building, the set of associated receivers, the receiver set facade, shall be split into a lower and upper half based on the median value of the calculated levels for each building. And I will give an example later. In case of odd number of receiver points, the procedure is applied excluding the receiver location with the lowest level. Then for each receiver point in the upper half of the dataset, the number of dwellings and people living in dwellings for that building block, shall be distributed equally to those remaining receivers in the upper half of the dataset. So that, of course, the sum of all receivers in the upper half of the dataset represent the total number of dwellings and people living in dwellings. So, a lot of information for you to swallow. Let me switch back first to predictor. Okay, so this is the end result of the EU population option. So here you set, in fact, in the main line, that is the important information. Here you see that there are in total for this model 56,000 people, 24,000 dwellings, and there are 13,013.13 people living below 40 dBA LDEN and 697.85 dwellings lower than LDEN, etc. So the LDEN, the LD, the LNight, the L evening, they're all shown here in 5 dB noise classes for the people and for the dwelling. Not only that, but also all buildings are presented here. So all 50,000 buildings are presented in this table. And for every building, you can see how many people live in that building, how many dwellings are attached to that building, and then also again the split up over the 5 dB noise classes. So there's a lot of information in this table. You can copy the table to Excel by using this option right below, or you can save this full table to Shape, then all 50,000 or whatever buildings, including those attributes, the EU population exposure attributes, are saved in a shapefile. Now I switch back to my presentation. Okay, so this was method 3. Again, I repeat that predictor checks which address points are located in which building block, and then cumulates the number of dwellings and people for that building block. And that's what's happening if you click on the EU population exposure option in predictor. So address points are of course very important. I've shown you that for the importing of GIS data. And then also the building properties are very important. Like I just explained, you need to know the designated use in order to select only those buildings that have a residential use. And the building type is important to select method 1, method 2, or method 3 within the residential buildings. Okay, example. This is an example of one building. There are 3 address points in this building. The cumulated number of dwellings is 3 dwellings. The cumulated number of people is 5 dwellings. So there are 3 dwellings in this building block and 5 people are living in this building block. If you choose method 1, the most exposed facade, then predictor will check all the result levels of the receives around this building block and sees what is the maximum number. Well, that's 68. So if you choose method 1, 68 decibels will be assigned to 3 dwellings and 5 people for this building block. That's method 1. However, if you choose method 2, the length of represented facade, then for these 7 receivers, predictor checks how long is the facade attached to that receiver. And remember that I told you during your receivers at facade creation, during part 2, that predictor also calculates the length applied to that receiver. So every receiver in its description has the facade length. If I switch back to predictor, let me close this one. If you double click on the receiver, you see that in the description, the length is 3.34 meter. And that's being added to the description when you use this create receivers at facade option that I've shown you in step 2. So then, depending on the length of the facade, you divide the length of the facade by the total length assigned to all the 7 receivers. Then you see that 13.12% is represented for 68 decibel, and 30.12% of the 3 dwellings is 0.39 dwellings for 68 LDEN, and 13.12% of the 5 people is 0.66 people assigned to the 68 value. And that's similar done for all 7 receiver points. So all 7 receiver points contribute a little bit to the amount of dwellings and the amount of people exposed to noise, depending on the length of the facade attached to that receiver point. So that's method 2. Then we have method 3, the medium value. Again, the 7 receivers. It's an odd number of receiver, so you have to forget the lowest value. That's what the method said. And then keep only the 3 highest value, or in this case 6, half of the data set, the highest half you need to keep. So you end up with 3 noise levels, 68, 68, and 64. And then the 3 dwellings and the 5 people are equally divided over these 3 noise levels. So 1 dwelling is 68 and 1.67 people is 68, etc. So 1 dwelling is also 64 decibel LDEN, and 1.67 people is also assigned to 64 LDEN. So those methods are implemented in Predictor, and so that will save you a lot of work. So you don't need to use a GIS set, a GIS software, to do this exercise. Predictor has implemented this exercise. Like I explained, I expect that this medium value, method 3, will be used most unless you know that it's a single dwelling. That is a single dwelling. Then you will use method 1, the most exposed facade. But as you can see, it really it makes a difference if it's method 1, 2, or 3. You can end up with more or less dwellings exposed to noise, according to the methods. Sorry about that. Then, like I explained, this is the interface you are using. And then explain a little bit more about the interface. Here you select the residential use based on the building property designated use. Then you select the building property based on building type, and you assign a certain building type to either method 1, method 2, or method 3. In the grouping system, you can select the group, and then you do a start. The start gives you this table, and the headline, the total line, that's the most important one, because that is in fact the data that you need. You can save this. You can copy to clipboard this table. You can copy it to clipboard, and you can save it to a shapefile. If you copy it to clipboard and paste it in Excel, it looks like this. It's simply a spreadsheet. Then, of course, you can make a nice graph in Excel. You can here you see all the LDEN values. In this case, the number of should be dwellings exposed to noise lower than 40 LDEN, between 40 and 45. Etc., etc. You see that between 60 and 65 LDEN, there are the most exposed dwellings, and then higher than 65 are less than the most. But this is the distribution of the number of dwellings exposed to noise over 5 dB noise classes for LDEN, for the day, for the evening, and for the night period. And so this is for dwellings, and you can create, of course, a similar graph in Excel for the people. The number of people exposed to noise in 5 dB noise classes for the LDEN, day, evening, and night. Then you can, like I explained, you can also save it to shape, and then you can open it as a background map in Predictor. And maybe not everybody knows that this is an option, but if I open as a background map, view, background map, let me see if I've got it here. So if I show this file, then you can also in the background map option in Predictor, if you select the shape file, then you can select either on a single value or a unique value. You can make a thematic presentation on all the fields that are available in the shapefile. And as I explained, all those 5 dB noise class fields are available. And then, for instance, on the people count, you can say, well, I want to color all buildings green if it's only one person, between yellow if it's between 1 and 2, etc. So then when you do a close, and then of course I need to, because now I've got the background map and the normal building, so I need to deselect the normal buildings. So here you've got a colored situation on basically on all the, and then also remove the receiver points because those are not that nice. So this is a thematic colored map based on the shapefile that you have created using the EU population option. So this is also a nice, and you can do it for people, for dwellings, or select all the houses that have a exposed level higher than 55, or etc. So you can do all kind of nice presentations in Predictor using that shapefile that has just been created. So coming back on the flow, this is the main flow that I've shown you over the last 4 webinars. And the first option is, of course, to import the GIS data. You import the buildings, the road, the railways, the height lines, the ground regions, the address points. And also you can import the agglomeration boundary as a diff area item. And note that for buildings, you need to include those properties, designated use and type. Those are important when you import the GIS data. Then we've created the receivers around facades, and you can select the buildings within the diff area with the residential designated use. That's a very easy reuse of this diff area. Then use the menu option batch create items, receivers at facade. You need to check the option add facade length. You need that facade length for method 2. And then for contour calculations, you can also copy the diff area and paste it as a grid. And then you automatically have your noise contours within the agglomeration boundary once calculated. Then you need to tile your model. First, it's important you create your groups, for instance, for industry, road traffic, and rail traffic. Distribute your sources over these 3 types of groups. Then set the calculation settings. The fetching radius was important, and the reflex was important. Then use the menu option tile model. And note that while using this model, the tile model option, you should set the buffer size the same as the fetching radius. I've shown you that in the previous sessions. Then you calculate the tiles using either local or cloud calculations. Then you import the tiles in the main model, and then you open the main model and use the menu option model import tiles, because then all the results are coming back in the main model again. And the main model can be used for the EU population exposure option, like I've just shown you. So then use the menu option results EU population exposure per group, because you need to supply the data for road traffic, for rail traffic, and for industry separately. And if you also want to divide between major roads and other type of roads, you can of course create subgroups. You can also create the EU population exposure for those subgroups. That makes sense. And then you export to GIS or to Excel. And you can copy the EU population table to clipboard or paste it in Excel and then paste it in Excel, or use the save to shape option to save it as a shapefile. Well, that in 7 steps is what I've shown you over the last 4 webinars. So it's now time for your questions.